We'll be talking about data security and data science, and he is the director of software development at WinMagic, and he is currently also a PhD candidate at the University of Toronto.
Thanks, Mary. It's getting a little late, but I promise we'll be done by 9 o'clock. So data security and data science, I thought this was an interesting topic to discuss and cover. Partly because WinMagic is a data security company, so they actually make sure that your data is protected. And then I have an interest in data engineering and data science, and then these two areas on the surface seem to be a little separate, but in reality there is a lot of data security and data science as well. So I started digging a little deeper into this area, and I found it quite fascinating. So this presentation is just my initial findings on this area, and I thought it would be nice to share it with everyone else as well. So yeah, thanks Mary for the introduction. I'll skip this slide. So data security in data science versus data science applied to data security. So there's two separate things. I just wanted to distinguish them. So first, let's talk about these three areas. We have data science, data security, or cyber security, and big data technology. There is a nexus, and it depends on how you actually look at it. Are you looking at how does data science is used in the field of data security, or how is data security being done in data science? And what these two ideas are, I'll just explain that as well. So first, DS applied to DS. Data security, data science applied to data security. I'm confusing myself as well. So the idea is machine learning, data science, data analytics, call it what you want. There are applications of that in various domains, in various spaces. Data security or cyber security or information security is just one other application of data science. There are many different use cases. I have some of them over here. I won't go into them in detail. I just wanted to explain that this is an data security is an application area for data science. You can use machine learning algorithms to find who is trying to hack the networks. You have these huge volumes of transactional and operational logs. You can use machine learning techniques to actually parse through all of those logs and come up with insights that can be used to better direct your business resources or technological resources. So that is one applicable area. I'm not going to talk about that today. What I am going to talk about is data security in data science. How do you protect your data? How do you make sure that no person, unauthorized person has access to it? How do you not lose track of the data? These are things that we need to be worried about as data scientists or as data engineers or as people who are responsible for developing and setting up data engineering platforms. We need to be aware of that. How do we preserve our data? How do we protect our data? What are the safeguards that need to be built around these data systems? So, more and more data is being made available to all of us. We are using those data in different professional and educational roles. We need to preserve it, we need to protect it. But why is it becoming so important? What are the reasons for this that it's now becoming a hot topic of discussion? Well, there are a few driving forces. The first is consumer concern. We as producers of data, individuals who are producing data on a constant basis, are more concerned as to what our data actually is being used for, where it's being traded, who is it being traded with, where is it actually being kept? Is it kept within the geographical boundaries of the country that we're living in? Is it being exported to other countries? So there's lots of discussions happening amongst individuals on this topic. So that is one area of concern. And companies are being more aware of this as well. Consumers are asking these questions before they were not asking these questions. The second area is media reporting. Data breaches, or even if it's not a data breach, even if it's a legitimate use of data as per the corporate policy, but if that gets reported that this data was used in such a manner, it becomes a big deal. Does anyone remember Cambridge Analytica? Facebook, right? Now that was a legitimate use of your data that you had handed over to Facebook. Facebook was retaining and keeping all of that data. The company was allowed to do certain things as per the agreement that you had given, or you had said, yes, I can do this, or yes, you can collect this data. So all of those were legitimate uses as per the agreement that you have with the company, implicit or explicit. But it became a big deal because the media part was of it, and it was actually used to influence different kinds of elections and decision making. So this is also becoming a big area of concern. Companies are becoming more aware of these things, and they want to make sure that they have a good reputation to keep. Compliance and audit. They are internal governing controls in any organization. Compliance is one, audit is another. They are two sides of the same coin. Companies need to make sure that all of these regulations that they need to comply with are being met, and these are being flagged at an internal level as well as an external level. And finally, government regulations. And I'll just probably spend a little more time on this slide as well. So I have these things in more detail mentioned over here, but I won't go into the slides. Government regulations. Has anyone heard of GDPR? So GDPR stands for General Data Protection Regulation. It's an EU-specific regulation, but similar to these other regulations as well, in addition to the more domain-specific regulations. But talking about GDPR, it basically says that controllers of data, so companies who have access to your data, who are storing your data, who are managing your data, they need to comply with certain government regulations which are part of GDPR. They cannot, if they are going to collect data, they need to have explicit permission from the producers of data, the people who are producing the data, like myself and yourself, right? We are generating data. So these companies need to have explicit permission from us that they are going to be collecting our data. They need to inform us what this data is going to be stored. They need to be very upfront about where this data is going to be kept and what kind of purposes it's going to be used for. Now this is causing a big problem to organizations because previously no one thought about all of these things. Previously you kept data, you stored it into a database, you used it for whatever purpose you wanted, and you did not really care about any of the thing. But now there are government regulations which are saying that the data belongs to the individual, it does not belong to the company. Previously this was used as an argument. Hey, we are collecting all the data belongs to us. So that's not the case anymore as far as the EU is concerned. I forget when it's coming into force, either in 2018 or 2019 it's coming into force. So now there's this huge scramble to, in countries who are operating in the EU, how do they actually comply with GDPR, and it's a big discussion point here. So, because there are so many concerns around data security, where should we start with? How should we handle all of these issues? There are many different aspects of data security and data science. So I aggregated them in three areas: protecting data at collection, protecting data at source, and protecting data when it's being used. And I will spend a few minutes talking about each one of them separately. So protecting data at collection. What this means is that there is data which is being collected, or which is being absorbed, or which is being generated from different points. When you're using a mobile phone, data is being generated at that point. When you're going and swiping your card at a POS machine, data is being generated at that point. When you're actually typing something online, data is being generated at that point. So there are various ways where data is being generated and so those are collection points. So you need to collect data from there and actually bring it to a central repository, a central place where it can actually be used for different reasons. So the first portion is that preserving and protecting and making sure that the collection points are secure. That is the first area. This is a typical data lake architecture, but it can be any big data architecture that you can think of. I just picked this up as convenience, and data lakes are very popular these days. So in data lakes, on the right side, you have all of these points where data is being generated. And then you have all of these integration mechanisms, either batch file transfers, or whether stream transfers, or whether accessing data to APIs and code APIs and so on and so forth. But essentially, this is these are connection points. This is the mechanism in which it actually is brought into a data lake. It could be an enterprise data warehouse as well. So just generally, do people know the difference between enterprise a data warehouse and a data lake? So a data warehouse is where you have these disparate data sources or other enterprise systems. They are all brought together, converted in a similar manner into one large data warehouse, which probably has a star schema. So there's lots of data manipulation and transformation that actually takes place. In a data lake, you can actually retain the original format of the data. It could be in different formats. It could be in documents. It could be in the form of documents, text documents. It could be in the form of video clips. It could be in the form of structured data. Yeah.
What is ODS?
ODS?
Or OLTP or ODS?
Online data sources, something like that.
Oh.
OLTP is online transactional processing. Right?
Yeah, Oracle is doing OLTP a lot, yeah?
Yeah, most systems, so that's a traditional way of transactional processing. That is it. Okay, so one more thing is, so now the data sources can be external, so the connection points can be external to the organization or can be internal to the organization. So in the data lake architecture, external data sources are also called stream fed because it's trickling like a stream downhill into one data lake. The idea is that because these are external to the systems, they can be different ways that they are being connected, and there can be different ways of preserving and protecting that as well. So you need to be very careful about what those protection mechanisms are, how they are actually going to be brought into your system, the kind of conversions that need to be done, and the kind of security measures that need to be placed to bring external data sources without having your internal systems compromised as well. So the upstream nodes which are external to the organization need to be considered, the security angle that needs to be considered. This is opposed to internal data sources, which is known as spring-fed, which is bottom up, because springs actually come from the ground. That actually also feeds your data lake as well. In internal data sources, there's less of a security concern because presumably it's all being controlled by enterprise policies, IT policies, the same level of security measures are going to be there as your primary data warehouse. So there is less of a disparity, there's less of a concern around there as opposed to external data sources. But it's still something that we need to be aware of or knowledgeable about. Now, when you're bringing data into your data lake or your enterprise data warehouse or your database or whatever structure that you have, there has to be an understanding of the amount of data that you can bring in or what type of data you should be bringing in. So that is where the goal and scope of analysis come in. So if you do not need all the data, then don't bring all the data. Just bring a level of data that you need. You do that by understanding what the problem you're trying to solve, what the goal of the analysis is, what the purpose is, and just identifying the data sources that let you solve that problem that you're trying to solve. There could be lots of restrictions that prevent you from bringing this data. So you need to be aware of all of those things before you say that I'm going to bring all the data that I have access to. And also cost is one big reason because some of this data is not free. It is being paid by your organization, so you need to justify the cost of data acquisition as well. If you have external systems, they may have different security measures as well. So in order to integrate that, you need to have authentication gateways. Those, they can be a different authentication for one data source, upstream data source, whereas your internal system can actually have a different authentication mechanism. So think of it as a reverse proxy, where someone who's trying to access, or you're trying to access an external system, you actually go through some authentication gateway or a reverse proxy, and you have a different authentication mechanism, and that reverse proxy or that authentication gateway has a different authentication mechanism from the data source that you're actually picking it out. So this is something that can actually help you out. So if you have external systems that you're trying to bring data in, you may want to consider using authentication gateways as well that allow this handshaking of this exchange to happen. And of course, that needs to be secure as well. For example, using secure communication and transportation mechanisms like SSL or TLS or so on and so forth. In fact, SSL is no longer being used. It's TLS 1.2 or 1.3, which is the latest version of TLS that is that is being used by authentication gateways or other reverse proxies. So that is protecting data at the collection point. What about protecting the data that you have in-house, in a database, in a data warehouse, or in a data lake? That also needs to be done. Data sources, such as a data warehouse or data lake database, need to be secure for obvious reasons. You don't want anyone to actually connect to the database and actually retrieve the data. So credentials, having database credentials is one level of authentication, that is fine, but you want to have an additional level of authentication as well, or you want to have some kind of protection mechanism as well. So your databases need to be strongly preserved. You don't want anyone in your team to have access to the database and just pulling data at random whenever they feel like it. So these are typical IT concerns whenever you want to authenticate or authorize anything, any resources organization, whether it's data or whether it's any other system. You need to worry about the administration, the authentication, and the perimeter security, how you're going to authorize it, and the audit and the data protection. Authorization and authentication, they are two separate ideas. Authentication is when you are trying to see if a person can actually access a resource, is permitted to access a system. No. Authenticate is when a user is authenticated using certain credentials. So I may log in onto a system, and the system will actually authenticate my login and password and say, yes, indeed, this person is actually allowed to access the system. Authorization is when I have access to a system, am I authorized to access all the different areas of that system? So think of it like this building. I was allowed to walk into this building because I was probably authenticated with some of my credentials so that this person can actually walk in. But I'm not authorized to enter each and every office in this building. I'm not allowed to enter each and every meeting room in this building. So there are two levels of security. One is authentication and one is authorization of the different persons. So both of them need to be actually built in. So if you have a research team, if you are a data scientist, so if you are someone who is responsible for setting things up, how do you want to protect your databases? How do you want to protect your places where data needs to be? The first is employ the principle of least privilege. What that means is that only give a person enough access for that person to do their job. Don't give any more access to that individual. If that person just needs one table, give one table of data. If that person needs access to all of the data, access to all the schema, but just give him access or her access for the last 1 year, if that is all that is required. Don't give the person access to the last 10 years of data. So these are things that you can actually think about. Employing the principle of least privilege. Second thing is protect your platform, your entire data engineering platform. You may have, for example, if you have a group, if you're using a group, now there are maybe a dozen components to this entire solution. Maybe the person doesn't need access to all of the components. Maybe they just are interested in the data ingestion and storing it in the database. That's one guy's job. Another person's job would be just to do the data visualization. They're not concerned with the ingestion of data or thereabouts. So this is something that you can also figure out. What are the components that the person needs access to, and only providing access to that particular component, as opposed to the entire ecosystem that we have built up and set up. Network isolation is another area. Typically, you have in an enterprise setting, the data science team and some of the data scientists in the group can actually agree to this. They are kept separate from the rest of the organization just because they have access to very critical and sensitive data and don't want anyone to have actually access to one of those data systems. So generally there's a separate subnet that is set up, or it's probably housed in the cloud. I work with the research engagement with Logos, and I know that their data science team actually have their own Azure setup just because they wanted to keep it distinct and separate from the rest of the organization. So these are things that companies actually do in order to make sure that even if there is an inadvertent access, someone has access to the system, the systems are compromised, but because there's a level of network isolation, the person cannot go and access the system itself.
Are you aware of any methods to protect the data against tampering? Let's say you have all these measures, but a skilled hacker can get into your system and not delete the data, but tamper with the data, yeah? So how are you protecting against that?
So there are several ways actually doing that. So there are lots of vendor solutions that actually protect against that. For example, Oracle or IBM or any database manufacturer, they have these logs which can actually indicate the kind of activity that is being happening on the system. Now, one could argue that, okay, fine, a user can come in and change things, and then the admin will actually, of the database will actually figure out that these are the things that are changed. But then what if the admin actually goes and changes things? Would that be detectable? Then yes, these vendors actually provide a second level of logging, which is stored outside of the system on some other system that shows information, things which are being changed or modified by any user in the primary database. And the secondary system, the admin of the database does not have access to that secondary system. So that's a second level of protection. You have systems, IBM's Tivoli suite actually has certain systems that allow you to log all of these activities which are happening in the database. So vendors who actually have these kind of systems in addition to that, if you are using blockchain, then you can always through hash understand if someone has actually made changes to a previous block of data. But
I think Oracle does row-level hashing as well, right? But that's not probably for a security perspective. I think
because you can actually compare the hash value of the table. I know that they do it at some level, but I'm not sure whether they do it at a row level, so that you can actually indicate that these rows have actually been tempered because the hash values will be not my hash. Sorry, any questions?
That works if the data is static, but if the data is dynamic and always changing, hashing doesn't do much. But I was going to say, like, all this is consideration of human accounts and their access to the data, but machines have full access to the whole database, right?
So,
and this is where like the break-ins are more likely to happen, and the tampering of the data is going to be less visible, right? Because you've got a web server. The web server has full access to all the tables because it has to, and then the intruder comes in, acting as another outside user, and is modifying data.
That is entirely true. But as any security professional will tell you, the weakest link is always the human user. So most times you're actually trying to protect the systems from a few human users as opposed to machines. Because if your systems are not secure, then yes, hackers can actually come and actually impact. And that's what we're trying to do. We're trying to make sure that systems are more and more secure. But it's always trying to make sure that people are not creating these open holes in your system security that anyone can actually come in and access.
So there are cryptographic protocols that are tolerant both to having adversaries or n number of adversaries or n number of adversaries out of n number of total users, which are tolerant to having people that are supposedly both exist to manipulate your system, right? So, but the idea is that you can bring enough trusted people together to recreate what you have. So there's well-known protocols that have been published and studied extensively in the crypto.
I'd be interested to read more on that. So that's probably an application of data science in the field of data security, right? Yeah.
So,
because I know
the group out of Waterloo, the trust group, so they work in data privacy as well. So there's literature from you guys work on in terms of private information retrieval, zero knowledge proofs. There's a whole bunch of other things and these are just advanced things, not even simple things that you can potentially do multi-party computations. So there's a lot of literature out there in the crypto world that should be applied to.
Yeah, I should definitely read up on that. Thanks for clarifying on that. Talk to you later. So, moving on, so data encryption. Data can be encrypted at various levels. Not only can it actually be encrypted in transit, and that's where a lot of these security protocols actually come in, but it actually can also be encrypted. It's called data at rest, where you actually all the data that is stored on hard disk or USB or some of it removable media, that is also encrypted. So encrypt all the data that you want, especially the one that there are concerns around the sensitivity of the data, for example, customer data or cardholder data or things like that, where you want to actually health data that you want to protect. Databases can be encrypted, files can be encrypted, your USB media can be encrypted, all of that can actually encrypt that. and just give access to individuals who need to have that data, so they can only decrypt it and use it. Data governance and IT governance, within IT you have data governance, a small space of how data should actually be protected and preserved and stored and used and distributed. So there are certain guidelines on how data can actually be used. Pretty much every major domain where there is sensitive data being managed and handled actually has guidelines. PCI DSS for payment services, HIPAA for health services. In addition, other companies who don't have these kind of regulations, who don't need to follow regulations, they may have their own, general policies like they may need to comply with COPEC or the Sarbanes-Oxley Act, things like that. So there are always these governing regulations or compliance policies that organizations need, for standards that organizations need to comply with. So make sure that those are things which are going forward. If your organization actually is enforcing them or is recommending them, make sure that they actually understand what those mean and how you need to be following them. Okay, the third area is protecting data in use. So now you have sourced the data, it's stored in the database, it's stored in the data warehouse, it's stored in the data lake. You have protected the data lake, you have protected the data repositories, and you know that it's no longer going to be messed and accessed by anyone. So now you need to consume the data, you need to do analytical modeling, you need to come up with some actionable insights. As a data scientist, you're supposed to be doing all of these things. So how to protect it while you are using it? So you need to be aware of responsible handling of data. Don't leave it lying around. It's just like a piece of paper with confidential information written on it. Don't leave it on a desk for anyone to actually pick up and walk by. Do not keep it on a USB, take it home and lose the USB on the way and unencrypted USB. So it's general common sense guidelines. If you're not supposed to take your laptop home, don't take your laptop home. These are just common sense guidelines which every organization actually would be enforcing or letting you know, making you sign this corporate policy document when you join. These are things that they usually have written down. Anonymize your data if you can. If your data does not need to be in its original form, then try to anonymize it. There are manual ways of anonymizing it. You can actually do substitution of data, change John to person 1, Jane to person 2, anonymize it so that it no longer identifies individuals uniquely. Use some hashing algorithms to hash certain field level values so that they no longer are obvious or apparent. Or use some algorithm that actually, or tools, there are API tools that actually allow you to anonymize data at ingress points. So as it's moving to your data warehouse, will actually anonymize data for you so that it's only your database does not anonymize data. Or there are algorithms, I've not tried it out myself, but K-anonymization is an algorithm that supposedly identifies and anonymizes data for you. But it will be interesting to try this experiment out. I don't think I've actually used it before. But if you have, please let me know, because I'm going to try an experiment one of these weekends. Use non-personalized data if you need. So there may be alternate ways of coming up with insights from the data. If you can use a non-personalized approach, for example, if you're doing recommendation systems and you have the option of using a recommendation system that gives personalized recommendations, but both of them will do that. But one is using a non-personalized approach and one is more personalized approach. Then see if the non-personalized one can actually be as good as you would think, and use that rather than saying that I need to have individual level data in order to do a recommendation. Automate some of the activities that we make. So again, humans are the weakest link in here, unfortunately. But if you automate, thank you. It's been a long day. So if you automate some of the activities that are supposed to be done by humans, then you need to prevent people just doing things that we call state of delivery destruction actually happen. So you may decide to do your analytical modeling using a small subset of data. Once you actually build the model, then you're fairly confident that it's going to work. And you move things into production. Then maybe all subsequent iterations of refinement or ongoing experimentation can be done script. So no one has to do things by themselves, and all you do is just see the results of each iteration or each cycle and see whether your models are working the way they're supposed to or not. So that's it. So I promised I'll be done by 4:09. So conclusions, yeah. This is you need to be worried about data security in the space of data science. We can't assume that we don't have to comply with the rest of what the rest of the organization actually does. Generally, organizations are very paranoid about data security, and for good reason. You just like we would want Levi laptops flying around, we would not keep them, on our dash of the car, and so that people can actually break in and steal it from our car. We would not do that. It's the same concept with data. We should be very careful with data as it's being consumed, as you're ingesting it from external systems, as you're doing manipulations of that, and you need to make sure that people can't actually steal it. Thank you. So if you have any questions, I'll be here for
How about deleting data? The right to be forgotten.
Yeah, that's an interesting topic. So let's look at it from two dimensions. First is, if you have data in the organization, can you delete it without consequences? So most organizations do not allow deleting of data. They would archive it, they would mark it as not active or not current, but generally you would not actually delete data, because that means that you are erasing evidence of something. So even if you look at those professional activities, you don't go and say that I'm going to delete all of this stuff. You either mark it as inactive and then archive it separately. So that's something that organizations generally do. They don't delete data. Now the right to be forgotten, that's something I'm not going to go into. It's a big philosophical discussion. There are lots of experts in the space of data privacy who specialize in these kinds of discussions. If you're asking for my personal opinion, I think yes, I would like to. I've done some really stupid stuff, and I'm sure there's evidence of that on the internet. And yes, would I like that stuff to disappear? I'm sure that we all would like stuff to disappear. I'm sure I have pictures of myself on MySpace from 20 years back somewhere, which it would be nice if that goes away.
That's the focus in Europe, the right to be forgotten, yes. Where
that's GDPR,
sometimes
yeah.
The companies are forced to delete data. Yeah.
And I believe that's also part of the GDPR regulation, that you have the right to be forgotten. Because the data belongs to you, it does not belong to the controller. So if you tell the controller that you do not want this to be used anymore, and you have the right to ask for that to be deleted, for that to be gone.
So it is pretty legislative, right? There's no guarantees that they delete it. There's no way even they themselves can give you 100% guarantee that they delete it.
But legally, it is a bounding.
Yeah, so it's all legality. It's legislatively enforced. If you're looking for a technical solution how to delete data, none exists really.
Yeah. Because it's spread across so much, think about it. Let's suppose if it was centrally stored, the data was centrally stored in an enterprise, and you can say, okay, fine, I've deleted these records. But if it's been replicated throughout the organization by multiple data scientists who are doing work, or data engineers who have to do different things, now there's no way that you can guarantee that if you're deleting stuff from the central database, it's gone across the entire organization. Right? I could have downloaded a version, a copy of a database or something, and it's sitting on my laptop. And the enterprise can never give that guarantee that all instances of that record have been deleted from the organization.
But legally it is liable if they say it's not there,
So
but then it pops up somewhere.
So what they would do is they would say that this information is no longer going to be used in a manner that it should not be used. For example, in Google search, that record will no longer be coming up. So that's something that they can control, because they know that information comes from one separate data store. So those are things that they can try to make sure happens. But whether that data will actually go away completely, that's very difficult to do. But the regulation does say that because the data belongs to you, you have the right to ask that organization for the data not to be used anymore.
And I think there's some complexity to, if you've learned from a person's data, how do you remove the learning? If you've changed company policies, if you've changed recommendation systems based on people's data, how do you unlearn?
So that's an interesting topic, and there are activities that go around that. So if you want that data to actually be not used anymore, you would have to retrain your models that are built on that data. So those data sets, and that would actually show different behavior. For example, there, I think even in embeddings, something recently came up where there was this push to change, so it will tell you, based on location, your insurance rates vary, right? So it's location based to some areas that may be more prime, so the insurance rates, your car insurance rate will be higher, in other areas it will be more prime, so the car insurance rate will be lower. So I believe there was a push recently in India for that to change, where the location should not dictate your car insurance, only your driving habits should actually dictate your car insurance. That did not work out. So let's suppose if you had built a good model that provided a price based on all of these dimensions, and if you wanted to remove one dimension, then you could retrain your model so that actually would work fine. But that is again another effort. What is tricky is that if these things start happening, organizations, which they will happen, organizations need to be aware of how frequent to retrain their models or substitute algorithms or select different algorithms to actually do this exercise. That's something I'm working again on, that how frequently should this be done, and how do you actually minimize the cost of reading things as your underlying data actually changes. I'll take one more question and then we can wrap up. Yeah, Arman?
So, first I have a question, an interesting fact that a lot of people are actually working on using blockchain for data governance, and kind of contradictory to this whole conversation in a sense. There are a lot of instances, even if they are identified on a lot of these servers and people's computers that they can't even have access to, let alone go and delete. So that's aside, but can you elaborate a little bit more on the identification of, maybe a little bit harder type of the identification when it comes to, for example, you have, so I'll just give you an example of a case that we were witnessing a couple of weeks ago, which was interviews with clients in the sense of audio files. How do you actually identify something like that, or internal reports from someone else's organization? It's not as easy as switching John to person one. And then while you are de-identifying, you are most probably also losing a little bit of information. So do you have any tips in that regard, or have you seen anybody doing anything?
I've not seen anyone doing anything, nor have I studied that area, but it is a very intriguing and interesting problem, because most of the stuff that I've read on anonymization is based on structured data, where you actually have these very easily, the trick is to make sure that you're anonymizing sufficiently in order to come up with results, and not completely anonymizing, partially anonymizing or employing pseudo-anonymizing techniques. But if it's unstructured data, so text, voice, audio recordings, and so on and so forth, I'm not really sure how that actually would be handled.
So there is this notion of differential privacy that became really popular a few years back. And the idea is that it's really a tuning knob that you can add noise to your data and basically letting go utility. Like, so the more noise that you add, the better privacy you get, the less utility you get out of it. And then there's a lot of literature around differential privacy and the potential for different privacy techniques that can help you with structured analysis.
One thing that to add to that, I do know that there are certain, again, neural networks that actually allow you, you probably know this better, that allow you to identify separate voices that, for example, if there's a conversation happening in a room and there are 10 people talking at the same time, you can actually separate those 10 conversations or 10 different voices and have 10 separate recordings. So maybe that's one way of anonymizing, identifying a particular voice pattern and taking it out of the conversation so that it no longer is there, and only selecting the ones that actually are pertinent to your data analysis. So that might be one technique of data anonymizing for voice, for text documents, because when you're writing something, your style of writing may betray you. You can actually tell, and I know there have been studies on authors trying to identify the writing styles, they kind of, and especially this happens a lot when you have a case going on, a legal case going on, that when someone writes this letter or not, was this well written by someone or not. So you have these language experts which actually go attest that yes, indeed, this will was written in a style of writing of that person, so it is going to be an authentic document. So I don't know how that would translate to AI, and if AI is capable of reducing or determining that as well. That's probably something that was quite relevant to what you had presented earlier today. But yeah, I'm sure there must be techniques that do that. How that fits into anonymizing or adding enough noise into the document so that that pattern actually breaks down. That was an interesting application. Okay, so we are past 9, 5 minutes past 9. Thank you for staying here. Maybe we wanted to come down. Okay. No, I was asking where you was. Yes. But you're welcome to wrap up too.
Okay, thank you all for coming this evening. Drive safely back. Thanks also on pizza. And we're going to have the next meetup in the new year, I think. It's a bit busy, the end of the year.
Yeah.
Okay, cool. So have a Merry Christmas.